Alright guys, so this is going to be our next section of chapter 6. It's going to be a relatively short video. We don't have a lot to go over, and it's really just an introduction to the idea behind metallic bonding, not a lot of detail behind metallic bonding. So to get started, we just kind of want to review the idea behind chemical bonding is that things can combine themselves into one of several ways. One is going to be referred to as ionic bonding. We've got chemical, molecular bonding, and then we've got covalent network compounds. And the term covalent network is a really, I would say, broad term that kind of encompasses how metals tend to attach to other things. And the idea that metallic bonding is what actually ends up with the properties that we know of metals, things like the fact that they're shiny, that they're ductile, that they're malleable, which we're going to go over what those two terms really mean in the next slide, that they can conduct electricity and that they are really good conductors of heat, are all going to come together to describe how metals actually behave, or why they behave the way they behave. Involves the way that the electrons in metals actually interact with each other. And from there, we can talk a little bit more in depth about malleability and ductility. Malleability is going to be the ability for a metal or a substance to be hammered into thin sheets. And this is really useful. It's a really useful characteristic of metals because it's how we typically use metals is in thin sheets that may be rolled into tubes or that may be used as insulation, not insulation, as conductors and things of that nature. Ductility then is going to be defined by the ability of a substance to be pulled into a wire shape. So if we heat up this metal and we start pulling from one end to the other, we can form what we call a pretty stable wire. And so those are two major properties of metallic bonding, in addition to some of the more common ones you already know, like the ability to conduct heat and electricity, and as well as the fact that when you see a metal, you think shiny. All right, and that brings us to our first lecture question of this particular video, and there are only two. And this question has to do with what we just talked about. So the properties of metals have to do with why they are, or the way that the electrons interact in them. And what I want you to do is just to describe three of those properties. You can pause the video here, and then when you're done, go ahead and hit play. I'm going to move on. All right, so then we want to talk about the differences between metallic, ionic, and covalent bonding. And to give you a good idea, I want to review ionic and covalent bonding. Covalent bonding is going to be the sharing of electrons between two atoms. Covalent bonding typically only takes place in two nonmetals. And then ionic bonding is the giving up or donating of electrons to an atom in order to create an ion, and then ionic charges with opposite values, so positive and negative, are attracted to each other, and that attraction is what forms the ionic bond. I talked about characteristics of ionic bonding in the past. I've also talked about characteristics of covalent bonding in the past. The next thing we want to introduce is this idea of metallic bonding. And the way that metallic bonds are formed involves what we call a sea of electrons, and we're going to talk a little bit more about what that means, but the idea is that there's a bunch of electrons floating around in a metal because the first metals are, of course, found further and further down. A lot of times when we talk about metallic bonding, we're talking transition metals. So think D-level metals. When you get to the D level of our periodic table, the transition metals that run from group 3 all the way up to group 12, those metals all tend to have a lot of electrons. And so we use that a lot of electrons idea to refer to them as a sea of electrons. And that sea of electrons will overlap and interact with the sea of electrons in a neighboring metal. And so they form this like really intense and strong network between them as far as the metallic atoms are concerned. And to give you just kind of the basics behind the metallic model that we're going to discuss, the metal itself is going to have a whole bunch of atoms that are all going to be together. Remember that whenever we see a chunk of a metal, we're not just seeing one atom, we're seeing several atoms all together. Those particular atoms are all going to have orbitals that are going to overlap because they'll have either similar energy orbitals or the same types of energy orbitals. when you see these overlapping orbitals, what happens is the electrons that are on the outer energy levels, remember those are the ones we talk about bonding, most of the time we refer to them as the valence electrons. Those electrons are going to be able to go from one metal to another in those empty orbitals that we're talking about, or in the empty spots, if you will. Because this ability to jump from orbital to orbital and from atom to atom exists within metals specifically, our transition metals, we call our electrons then delocalized, meaning they don't have a specific location where they belong. They're allowed to move from atom to atom, and they can move in what we call little electron holes. That kind of leads us to this idea that when electrons are able to move around, they form what we call a sea of electrons. And those typically then order themselves, our metals then typically order themselves in what we would call a crystal lattice, just like we saw in our ionic compounds. Now, the difference is the electrons in our metallic atoms are not going to be they're not going to be held down to one location. Our ionic bonding, though, does have them held down to one location. From there, we just want to kind of say that this idea that the metal atoms have holes for electrons to jump from metal to metal, one, explains why conduction is so great. When we talk about electrical conductance or any type of conductance, electrons are moving through a circuit, right? So when we talk about electricity, we're talking about electrons moving. Well, the fact that metals have these holes or these empty orbitals for electrons to move means that we've created this path for electrons to travel. And that's the whole idea behind metallic bonding. It's that there's a whole bunch of holes that these electrons can move in. Since there are so many electrons that should be able to move, we call it a sea of electrons, and we just kind of put those ideas together and call it metallic bonding. Which brings us to our last question. You are free to pause the video here, answer your question, and then when you're done with our video. And you're good to go for that lecture quiz that we're going to have later on. Have a great day.